Partially. Okay. So this is summarizing this section. Yes, I am, Levi. All right, so now the big question of all these is the function linear? So we have to be able to tell, Caleb, put the ruler down. We have to be able to tell if functions are linear from tables. So right now you are thinking, and I want you looking at each of these tables, tables 1, 2, and 3. And I want you to think to yourselves right now, which ones are linear and which ones are not. Okay? Turn to your partner and tell them which functions are linear and which are not.
What was the linear? First one was second one. And the third one was
Okay, so let's see, Haley, which ones did your table decide were linear? 1 and 2 are linear. And what was your rationale for that?
Because on 1 it's increasing by 2, and on 2 it's decreasing by 6.
Okay, so these are increasing by 1 and these are decreasing by 6.
That one's 2.
Increasing by 2, decreasing by 6.
Yeah.
And Dominic, so why is 3 not linear?
They're not even.
They're not even?
They're not going up evenly, yeah.
They're not going up evenly because we go up 1, we go up 3, 5, and 7. Does anyone know what equation this would actually be?
Yes. No.
What is it doing each time to get?
Oh, it's a nonlinear equation.
This is nonlinear, that's correct.
Wow.
This is nonlinear. What's happening each time?
It's getting squared.
It is getting squared. This is y equals x squared. So what is this called?
Exponential. Quadratic.
It's a quadratic.
That's right.
All right, another thing we have to be able to do from tables is to recognize what the slope is. So Haley Asbury, could you help us out in figuring out what the slope for question 1 is?
Not really.
Could someone at your table help you?
No.
Nathan, could you help? All right, so Nathan, help us out. How do we tell what the slope is on question 1? Caleb, what do you think? How could we tell what the slope is for question 1?
You can tell by, like, for these ones.
For this one, this table.
Okay. You can tell, because it's at a constant rate, so like 7 minus 5 is 2, 9 minus 7 is 2, 11 minus 9 is 2.
Okay, so is it negative 2? Is that what the slope is?
No, it's positive 2.
Okay, so it's positive 2, because that's as we get more positive.
Yeah.
Okay, so the slope is 2. All right. Gracie, could you help us out and figure out what the slope is for question 2? Slope is negative 6. All right. Now, another important thing, Abigail, is that we are able to recognize what our y-intercepts are. So how do we figure out what the y-intercept is?
It's the thing that goes up and down.
Okay, that's our slope. Darren, could you help us out with the y-intercept?
I have a question. Can I charge my- Oh. Giovanni knows, he just knows it.
Giovanni, do you know what the y-intercept is for question 1?
You just told me, come on.
I don't know.
He's pointing at it.
For question 1?
What?
Oh.
Five.
Y-intercept is 5. I agree.
How do you know? Just told me.
All right. Sammy Lou, could you help us out with a intercept for question 2? For this one? Madison? 21, I agree. That's our y-intercept. And where x is 0, our y-intercept, that's where our y-intercept is, okay? Where x is 0. All right. Now, we also have to be able to recognize
Oh.
linear equations. So, right here, I'm going to number these. So silently be thinking to yourselves, which are linear? Okay. Your eyes should be up on the screen. All right, turn and tell your partner which of those equations are linear.
What was linear? 5x plus 2 is linear. 1/3 x minus 1 is linear. No, it's not.
Wait, no, what?
Y equals x is linear. Y equals 3x linear. Y equals x 3. 2, 4, 5,
All right, so Kaya, question 1 is what? Number 1 is linear. Caleb, what's number 2?
Linear is exponential.
Number 2 is
Number 2
exponential.
is exponential. Why did I say that? I looked at the word linear.
All right,
My brain thought
it is indeed. Haley Vanderlinde. What's question 3? Linear? But I thought it was inverse, guys.
No, because
Yeah, it's
because
inverse.
if you follow the equation,
No,
the
but you are
example
linear.
here for linear is y equals mx plus b.
Because it's in y equals mx plus b form. Who knows what 4 is?
Giovanni told me.
No.
Stop saying it.
that. Quadratic.
It's quadratic.
So yeah, we just went over that one.
Yeah, bottom.
Number 5.
Wouldn't that one be inverse?
That'd be quadratic.
Oh, I was thinking it's
Quadratic is to the second power.
quadratic.
Quadratic 3.
Wow.
Wow.
Yeah, I don't know the answer to that one.
This is a cubic.
Whoa! I knew it.
All right, and finally our last one.
It's
Linear.
variation.
It is inverse variation. Now the big thing. Our variable is in the denominator. That cues us off. All right, and finally, we have to be able to tell what graphs are linear. Which 2 are linear? Oh, I guess I never. 1, 2.
They're exactly straight, so they're linear.
Sammy Lou?
Do you want us to turn in the work that we did today?
No, just your homework. All right, hey, which of these graphs are linear? Focus up. Levi?
I can't concentrate. People are-
Okay, hey, voices.
Number 1, number 2 are linear.
All right, now how do you tell the slope between these?
5 and 7.
5, 7, and 3 and 4 should skew you off. Hello. Yeah. Peter, once I finish up for the day, we're almost finished. Okay. All right. Bye bye. Okay. How do you tell what the slope is from a graph? Have you guys ever done that?
Oh, yeah, it's right.
Rise over run. So this slope would be on number 1.
3/4.
So this would be 3/4. Very good. And our slope over here,
5/7.
just 5/7? -5/7 because we go down. Now, one thing I didn't go back through on the linear stuff, on these equations, where are our slopes?
Oh, it's what the X is behind.
Behind or in front of?
Yeah.
So it's in front of the x. So our slope for equation 1? 5. And our slope for equation 3?
A third, negative and third.
Negative third.
3.
And so that would leave 2 and -1 to be your y-intercepts. All right. Now, make sure you get your homework done. And that's all I have for the day.
Thank you. I'm a thanker. Listen to me say.